Today's lesson is going to start with a review about air masses, fronts, and low pressure and how that affects storm formation. And then we're going to move to talk about some newer things such as weather station models and hurricane tracking. To begin our review, let's start with air masses that affect us. And you'll notice in the picture that we have maritime polar in the northern part of the United States. And that means that this is air that is moist because it's coming from the Pacific Ocean, and it's cold because it's coming from the North Pole. And in the center, we have continental polar, and that's air that is coming down from Canada, and that air tends to be very dry because it forms over land, and it's coming from the North Pole, so it's very cold. And then off the Atlantic Ocean, swinging into the New England states, we have maritime polar air masses that come in. And those air masses are just like the ones we saw over here, coming in off the Pacific Ocean. They are cold and they are moist. Maritime means moist airs, air that forms over the ocean, and polar meaning cold. So the upper portion of the United States has very cold air. The bottom portion of the United States has very warm air because this is air that is warmed coming from the equator, so it's going to be called tropical. So all three of these air masses are tropical, and now it just depends on where those air masses form to determine if it's going to be maritime or continental. So starting over here, we have maritime tropical, and maritime again is air that's formed over the ocean, and so it tends to be very moist, and tropical because it's very warm. In the center portion that's coming over Texas, that air is dry because it forms over Mexico, and that's a large body of land, so it tends to be dry. And the air coming from that area is very warm, so that's continental tropical. And then we have maritime tropical, which is the kind of air that we get most often. Maritime again because it's air that's coming from either the Gulf of Mexico or off the Atlantic Ocean, and so it tends to be very moist. And tropical because it's warm. So that's a quick review of our air masses. Now we're going to start with our fronts, and fronts are located here. Let me size this down so you can see it, and maybe move this over so you can read all of it. Okay, so this is fronts and the type of weather that results from those. Make it a little bit smaller. Okay, the first front that we're going to review is a cold front. And you'll notice that when the cold air and cold air mass is on the advance, it literally pushes the warm air straight up into the air, and that's how cumulonimbus clouds form. I like to think of the cold air as being really big, bad, and tough. It brings the most severe types of weather. So only cumulonimbus clouds, and those are the clouds that form hurricanes and tornadoes, those only come from advancing cold air, which is a cold front. Now, I'd like to show you an animation of that. And let me move the camera a little bit more. All right. And so what you're going to see is a cold front. So you can see the warm air is sitting still while the cold air is advancing. It's the one moving, and you can see that it's got a giant uppercut. It's just pushing that warm air up, 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 and you can see that it's actually forming that large cumulonimbus cloud. So notice the direction of the front. The cold air is the one that's moving, or we call that advancing, while the warm air is kind of a sitting duck, and it's just waiting for that cold air to come by, slide underneath, and then punch it straight up into the air. Now, another type of front that we see a lot of is going to be the warm front. Let me get that where we can see that well. Okay, the warm front, let me just go like this. The warm front is the exact opposite. This is when we have a body of warm air, a warm air mass that its signature move, since it can only rise, is to kind of do a sleeper hold. So it's going to slowly creep up over and on top of this cold air mass. And as it does it slowly. So it's a lot weaker than the cold fronts, but it produces some rainy weather. And then, interesting enough, a whole lot of different types of clouds come with the warm front. And I want to show you that animation. So cold fronts produce cumulonimbus clouds only, while warm fronts, as you'll notice, as they gain elevation over the cold air, they start with forming some stratus clouds and then cumulus clouds. And then as they reach the upper portion of the cold air, you can see some of these cirrus clouds are starting to form. So they form all of the whole range of clouds with exception to the cumulonimbus. The lower elevation on top of that cold air, that's again your stratus clouds, then your cumulus clouds, and then if the cold air is tall enough and the clouds reach over that, it can actually form cirrus clouds. Okay, another type of air mass that we see most frequently is the stationary air mass. And this is like if you're playing chess where neither one wins. You have two equally matched air masses, a cold and a warm, that are fighting for position. And one will win for a little bit and then the other one will win for a little bit. And they just kind of swing back and forth, and really there is no winner. So what it produces is several days of very dreary weather. And to show you the animation for this one, get it set up for us, it looks like this. So you can see the cold air and the warm air, they're equally matched. And once they hit right along the front line right here, you can see that these are just moving slightly back and forth because there's really no true winner. So it brings several days of dreary weather. Now the very last one is the occluded front. And the occluded front is what I call the three-way brawl. And you'll notice that there's some cool air here that was overtaken by warm air. But then a larger cold air mass comes in and it advances forward. See how it says direction of front? It advances forward, and what it does is it pushes up on the cold and the warm. And so you have three air masses that are involved in this fight, or what we call the front. And a trick to remember that is occluded. Occluded is spelled right here up at the top, and it has two C's, and that's a way to remember that it has two cold air masses involved in it. Alright, so that's going to finish up reviewing for our fronts, and now we're going to move over to talk about low pressure and review some of those concepts. Let me move this back over here, and that's going to be on page 9. Okay. So we're going to talk about high pressure systems. Really, we're just going to focus on low pressure systems here. Now, I want you to notice in the picture that these white arrows indicate the motion path for high pressure and low pressure. If you'll remember, high pressure air is the air that's going to sink. So you notice those arrows are pointing down. And then they're also moving toward the low pressure. The high pressure kind of acts like maybe like a snowblower. It kind of blows the air down, where the low pressure sort of acts like a vacuum and it kind of sucks the air up. So having a high and low pressure system next to each other, they kind of feed in, the high pressure feeds into the low pressure. I want you to notice in here that with the cloud formation, if you notice the spirals, they actually are moving counterclockwise, and that's to indicate that that is a low pressure system. Low pressure systems are bad. They bring storms, and the way to remember the way it spins is to remember that going counterclockwise isn't normal. It's not a good thing if your clock is going backwards. So low pressure, the storms spin counterclockwise. High pressure systems, the air spins clockwise. All right, and then one more page to show you. Now, this is a very important concept that you need to understand about how fronts produce areas of storms and low pressure. So I want you to look at this picture Let me get it in view here. Let me make this a little bit bigger. Okay, so here's our picture. And what I want you to notice is that this cold air is swinging down, and then this warm front, this where the warm air is moving, it's swinging up. But what happens is that snowblower versus the vacuum kind of action, and you can see that it kind of creates a spiral formation where the warm front is moving counterclockwise, and it kind of feeds into each other, and that produces a low. So you can see the arrow moving down. If a cold front is moving down, and then the warm air is moving up, it creates this whole counter clockwise motion, and that is defined as low pressure system, and that's going to bring about some pretty nasty storms. All right, this is going to end the review portion. On the next video, we'll talk about some new concepts that will help you for your project.